Hey everyone, today we'll be going over Leetcode number 1029, two-city scheduling. In this problem, we have a company which is planning to interview 2N people. And what it needs to do is send half of these people to city A to interview them, and half of the people to city B to interview those. So we are given a costs array, where each subarray costs of I shows how much it costs to send the ith individual to city A, and how much it costs to send the ith individual to city B. Remember, we must send half of the individuals to city A to interview them, while the other half of the individuals to city B to interview those. In fact, what we want to return is the minimum cost to fly every person to a city, such that exactly n people arrive in each city. So we have an example here below where we have a cost array with 4 different costs, each for a different individual. So we know that the length of costs is 4, and therefore 4 is equal to 2n, making n equal to 2. This means we need to send 2 individuals to city A to interview them, and 2 individuals to city B to interview those. We see in the result that they decide to send the first person to city A, the second person to city A, and the third and fourth to city B. Therefore, in calculating our output response, we know that we will use the $10 needed to send the individual to city A for the first person. For the second person, we will need $30 to send a person to city A, whereas for the third and fourth person, we would need to use $50 and $20 respectively to send those individuals to city B. Therefore, we can calculate our output as 10 plus 30 plus 50 plus 20, and together this makes 110. I have drawn an example to the right which will help us determine our algorithm to decide which individuals to send to city A and which individuals to send to city B. Again, our length of the cost array is 4, making 4 equal to 2n, and therefore we must send n or 2 people to city A and 2 people to city B. One might start off by thinking to observe each cost subarray and send each individual to the city it costs less money to send that specific individual to. However, thinking like this, we would see that it takes the first person $10 to send to city A and 50 to send to city B. So we send them to city A and use the $10. Same thing for the second person, because it costs less money to send them to city A, so we use another $10. And the same can be said for the third and the fourth person. However, remember we must send n people to each city. So half the people must be sent to the first city, and the other half must be sent to the other city. So this algorithm will not work. What we need to determine instead is a way to compare how much less it would cost to send each individual to one city versus the other. So what we should do instead is take the difference between the two costs for each person and store that in the array. Say for the first person, we have 50 minus 10, which is equal to 40, and we store that in an array. For the next person, we have 20 minus 10, which equals to 10, and we store that in the array as well. 100 minus 10 is equal to 90, and then we have 60 minus 10 for the last individual, which means 50. We know that this differences array basically shows how much money more it would cost to send the individual to city B rather than city A. Therefore, what this means is that it would take $40 extra to send individual 1 to city B rather than city A. It would take $10 extra to send individual 2 to send city B rather than city A. It would take individual 3 $90 extra to send him to city B rather than city A, and $50 extra to send the last individual to city B rather than city A. If we sort this differences array in ascending order, we will now have sorted these array based on how much less it would cost to send an individual to city B rather than city A. Sorting this array, we would have 10, 40, 50, and 90. This 10 comes from the second individual, and this means that it would take this individual only $10 extra to send him to city B rather than city A. The 40 instead comes from this first individual, meaning that it would only take $40 extra to send this individual to city B rather than city A. The other two individuals would take much more money to send them to city B rather than city A. Therefore, when dividing this sorted differences array in half, we would rather send the first half to city B, rather the second half to city A. And this is basically the algorithm we will use for this solution. We want to create a sorted differences array where the differences is equal to the difference in cost between sending an individual to city B rather than city A. Knowing now how much additional money it will cost to send an individual to city B compared to city A, and sorting them in ascending order, we would want to send the first half of this sorted differences array to city B because we would know we would save more money by sending them to city B. And we want to send the second half to city A because we know that we would save more money to send these to city A. We can now highlight which individuals we will send to city A, which are the third and fourth individual, and the individuals we will send to city B, which are the first and second individual. We can now calculate our output. We know that for the first individual, we will be sending it to city B as we have highlighted it green. Therefore, we will be spending $50 to send him to city B. For the second individual, we will also send him to city B and spend $20. For the third individual, we will send him to city A and spend $10, and for the fourth, an additional $10, sending him to city A. Therefore, our output will be $90. Notice that in this algorithm, we are going over the cost array once in order to create the differences array. Then we are sorting this differences array and going through this sorted differences array to determine which individual to send to city A and which to send to city B. Therefore, the time complexity is going to be O of n log n. Going through the cost array only takes linear time. However, because we're sorting the differences array, the overall time complexity will end up being n log n. Let's go back to Leetcode and write up the solution. So we said we wanted to start off by creating a differences array. And this differences array would allow us to determine how much more money it would cost to send an individual to city B rather than city A. Then what we will do is we will take each individual in our cost array and destructure the individual into the cost for city A and the cost for city B. Afterwards, we can start filling up our differences array by saying differences.append, and we will append a subarray which will have the difference between the cost for city B and the cost for city A at its first index, or index 0. Then we will have the cost of city A and the cost of city B, which we will want to preserve. After this, what we will do is sort this differences array. Therefore, after sorting the differences array, we will have the first half being individuals we want to send to city B, and the second half being individuals we want to send to city A, because they are sorted based on this difference. Having achieved this, we can create a result which will be initialized to 0. Then we can iterate through this differences array. So for I in range of length diffs, and what we will do is say that if I is smaller than the midpoint, where the midpoint is equal to the length of diffs divided by 2, then we will increment our result by the cost to go to city B. And we know that the cost to go to city B is put at index 2 in our differences array. Once we pass that halfway point, we know we want to send the individuals to city A, so we will increment by the differences of I at index 1, because we know that we have put city A cost at index 1. And at the end, we can return our result. Let's make sure this runs and submits. And we see that it works. Once again, this is in O of n log n time complexity, where n is the number of individuals in our costs array, because of this sorting that we're doing to the differences array. Thank you so much for watching this video. I hope you found it helpful. Please give it a thumbs up and subscribe to my channel. I'll see you on the next one.